All right, so let's talk about the while loop. First of all, let me mention that there are essentially two categories of loops. So if you have loops, you end up with something called precondition loops, and you end up with post condition loops. So precondition loop is a loop that checks for a condition before going into its block. Post condition is a loop that goes into its block, checks for a condition at the end. Preconditions are the while loop and the for loop, and post condition there's only the do while, and we're going to talk about that. So the while loop is a precondition. That means that it checks for condition first and then it'll execute some statements. Basically, the condition test is a Boolean expression. It's a logical expression, as you recall. So this could be true or false. So that's the condition. You have the statements inside, and there's no semicolon. That is basically the bare bones structure of a while loop. There is no semicolon because, as you recall, if you put a semicolon at the end of this, it would mean a do nothing statement. So basically, the while loop is another exception that you don't have a semicolon at the end. Other statements, all these statements get semicolons, of course. With the while loop, you typically want an initialization, and I'll talk about what I mean. And also, you would need an updating statement over here. Oops, let's go back. So if this test condition is true, we keep on executing these statements. Let's just, without going further into the slides, let's just write a simple while loop together. So if I said int I equal to 0, and then if I said while let me write this with a different color. I is less than 5. Go ahead and print ln I. And then I would say I plus plus. So when you run this code, let's look at what happens in memory. So what happens in memory, and by the way, you could have your loops and you could program in static mode, or you could, let's say, have them in a setup function or even a draw function, right? So you could use them in static or dynamic mode. So here, basically, this is let's go with color purple. This over here is the initialization. So this is sort of our counter, if you will. It'll count how many times we go through the loop. This over here is the test condition. So it's the test condition, and this has to be a logical expression. So this is a logical expression. This is our statement. This is a statement. And here, this is really, really important. This is our updating statement. So if we run this, what would happen? We're going to have I as 0. So let me actually make a big box so that I can just cross things. So let's say we have I. Let's change the color. So I is set to 0 to begin with. And then I say while I is less than 5. So as long as I is less than 5, we're going to execute these statements. So while I is less than 5, print ln I. So let's just say this is memory. Let's just say this is actually not the screen. I'll just say what I mean is the console, because you're printing. So while I is less than 5, print ln I. So you're going to print 0. And then of course, you know, ln means you go to the next line, so you get prepared to write on the next line, and then you say I plus plus. So I will become 1. Then we go back to the top because it's a loop. Then we say while I is less than 5. Well, I is 1. Is it less than 5? It is. We're going to go back in here and we say, we print again. We print I, which is 1 in this case. And we go to the next line because it's print ln. Then we say I plus plus. I becomes 2. We go back to the top and check. I less than 5 again. 2 is less than 5. Sure. So we go back in. Print 2. I plus plus. This becomes 3. Okay. We go back to the top. Is I less than 5? Yes, it is. We come back down. We're going to print 3. I plus plus. So I is now 4. Right? So I is 4. We go back to the top. Is I less than 5? It is. We're going to print it again. So 4 is going to be printed. Right? Then we're going to say I plus plus again. So now I becomes, I'm running out of room here. So I becomes 5. So the value of I right now is 5. Is I less than 5? It's not anymore. So we're going to come out of the loop, and that's the output of our program, right? If I had said this, if I have, let's say if I put a print statement and say print after loop I is, what do you think is going to be printed? So it's going to say after loop I is, what's going to be printed there? The value of I, which is 5 in memory, right? If we made another change to this, so for example, if I had said in here, if I said I less than 5, if I had said I less than and equal to 5, 5 would also be printed here. So if I had said that, then I would have 0, 1, 2, 3, 4, and then let me take this. I would have 0, 1, 2, 3, 4, 5, and of course my 5 would be a 6, and then it would say after loop I is 6. You see, this is for the simple fact that I have the I plus plus at the end. So this is something that you could you could experiment with, and you could play with that while loop. Let's go and look at our slides. So let's look at the flow chart here. So the flow chart, you have the initialization on top. So the initialization is not necessarily part of the loop itself, right? Then you have the test condition, which you must have. You would have the statements, the update statements you could have, and then afterwards, if afterwards you have the other statements, let's say, right? So after updating, you go back to the top. If the test condition is true, you're going to keep going with the loop. If it's false, you're going to leave the loop and get out of it. So here's that example that we had. In here, example 1 is setup with I equals 0. You can see it's inside of setup, so it is in active mode technically. It is inside a function, and of course the output here is going to be 0, 1, 2, 3, 4. As long as this is true, we're going to keep on repeating this, and as soon as it's false, we're going to go to the last to the statements after the loop. So print ln without nothing inside, it's just going to print another end of line. It's going to print another sort of a new line for you. All right. Well, a couple of things before we go and look at other examples. First of all, if you have while, so if you have while true, what do I have here? So in here I'm saying while true, keep doing something. This is basically an infinite loop, right? Because true is always true, and I'll just say stay in this block of code as long as this condition is true. So this is an infinite loop, and it's basically going to crash your program or make your program non-responsive because your program is going to be stuck in here. Here you can kind of see I don't have initialization. I also don't have any updating expression. So also, going back to our previous example, if I have int I and I can set my I to let's say 5, and if I say while I is less than 10, and let's say print ln I. What is the output of this program? The output of this program is it's going to forever print 5, right? Because I is always going to be less than 10. I is always going to be less than 10, so it checks for I is always 5. It never changes. So again, you're stuck in this code block. What is missing here? What is missing here is I++, or technically, you could write something like I equals I plus 2. So you could have iterations that are more than just increasing by 1. Let's point some of these into processing, and let's see what it does. A little bit of warning: when you do have infinite loops, they're always bad news. So sometimes processing could completely crash and be a lot of problems. So you may lose all your work. So make sure you always save your work. So if it did crash, you could start things up again. So if you had I true, if you ran this, let's see what happens. So it says unreachable code. It actually gives us an error. This is because processing is smart. It actually catches this for us as a syntax error, which is great. Because if it didn't catch it as a syntax error, you could be going on and on and on and on forever. So it actually doesn't let you even run this, even though just because it's going to be an infinite loop. Let's try the other one. Let's say if we had int I set to 5 while I is less than 10, and let's say println I. So as I said, this is another form of infinite loop because we're not actually updating I at all. Let's run this. This time we didn't catch it as a syntax error, and you kind of see 5 being printed over and over and over again, and I am not able to, and it basically doesn't stop. So I'm trying to go on stop. I press stop, and it stopped. So let's have another println statement. I'll say done at the end. Let's try running this again. Kind of see 5 kind of keeps on printing, and it's printing so fast that it looks like it just shows 5 and you never get done. So the only way to end this program is to actually press on stop. And sometimes in processing, when you do press on stop, you still end up crashing, which looks like that's what's happening to me. Oh no, good. I was able to stop it. So if I add the increment and the updating character, then this should print. So what do you think it should print? Maybe pause the video right now and think about it for a minute and predict what it's going to print, and then start me back up. Okay. Hopefully you took my advice and stopped the video and figured it out, but this is what you should be getting. So you should be getting 5, 6, 7, 8, 9, and then we come out of the loop and you're done. So you print 5 and then you keep on going. So the memory diagram would be the same as before. Let's go back to the slides and let's look at another example. Okay, so here we have a string instead of a integer. So if we have a string, in memory, we have engg to 33. So let's go up. Basically, you have engg, this is space, and then 233. Okay, and we have an int I, so that's our initialization, set to 0. Then we say while I is less than name.length. What is name.length? So if you recall, name, so this is name. Name.length gets the length of this, which happens to be 8. So we have I set to 0, and this is all in memory of setup, right? So let me say println name.char at I. Char at I is char at 0, and you recall the indices being 0, 1, 2, 3, 4, 5, 6, 7, right? So println name char at index 0, E is going to be printed out. So first you're going to get E printed out. Then I is going to become I++. So then I is going to become 1. So we go back up in the loop. I is still less than 8. So this is true. We're going to execute this again. Now print out name dot char at 1. Char at 1 is n. And I is now set to 2. Okay, so then we go back up. 2 is still less than 8. So we go back in. Char at 2 is g. Okay, that's great. I plus plus again. I is going to become 3. We go back up. 3 is less than 8. So we're going to print out name.char at 3. So another g is going to be printed out. And so on and so forth. So the output of this program ends up being ENGG 233. So when you print out the last one, I actually ends up being 8 after you print out the last 3. When you go back to the top, 8 is not less than 8. So you're done. And that's going to be the output. And also, when you finish the loop, you're also going to get another thing printed out on the screen. So at the end of the day, you're going to get this statement also printed out in the console. So there's going to be there are I, and I is going to be 8 characters, because that's what you do when you count through the whole thing. So when you're done with this program, the value of I is actually going to be 8 in memory.